Okay, today we're going to wrap up this parabola thing. We've talked about moving stuff right and left and up and down. Today, I hope we can see where that some of that moving comes from. This is very important. This is called the general quadratic equation. This is always going to give us that parabola because of the x squared. If the number in front of x squared is positive, our parabola is going to go up. If the number in front of x squared is negative, our parabola is going to go down. And this is an interesting little formula. You need to make note of that formula when you start to do that homework. And I think when you do a quiz, you're going to run into that too. The x value of the vertex of a parabola can be found. And notice that the b value is in the form up here, what comes in front of the first degree factor. And the a value is what comes in front of the second degree factor. This will always give us the vertex of a parabola. It might not be the easiest way to get it, but it will always work. Let's take a very simple one. We've already done this one. I don't have a b value. The b value is 0 in this particular problem. So the x value of the vertex is going to be minus 0 over 2 times 1, which comes out to be 0. Well, we've drawn this particular graph several times. When x is 0, y is 4. When x is 1, y is 5. This thing is symmetric with respect to the y-axis, so x is minus 1 is going to be 5 out here again. So the formula works even when you don't see the b. The b value is 0, so that gives me the x value of the vertex of a parabola. Now, certainly it went up because the number in front of the x squared was positive. So the big deal is, how do we move this stuff around? Well, let me do it with a simple one first. Still a parabola. It's still going up because of the fact that the number in front of the x squared is positive. Let's do something a little bit different in this one, though. Let's find the intercepts. So in this particular problem, if I let x be 0, I got 0, 0, minus 3. So I get 0 minus 3. So my y-intercept is minus 3. Now, to find the x-intercepts on any curve, you let y be 0. Well, this brings us all the way back to the second class, because this is a general quadratic equation. And one of the easiest ways to solve the general quadratic equation is to factor it. This factors into x and x. This is 3 and 1. Now, the negative is here. Go with the biggest factor, so it goes with the 3. Since the tail end number is negative, these has to alternate. This is negative, and this is positive. So to find my two intercepts, I solved these two linear equations. Now notice what we just did. We let y be 0, and we found x to be 3. I let y be 0. I also found x to be minus 1. Now, the reason I like to use this one is because it also brings out another feature of the parabola that makes it pretty easy for us to deal with quite often. Find your two x-intercepts, 1, 2, 3. So my intercept is 3, 0. My other x-intercept is minus 1, 0. And in this particular case, we also had a y-intercept of -3. So when x is 0, y was -3. Now, notice that I have this intercept, and I have this intercept over here. So that means that curve has to come down here, and it has to go back up here. I need to move this thing out of my way so that I can emphasize the vertex. So that point is 0, -3. Now, let's go back to that little formula that we just had. The x value of the vertex is -b divided by 2a. Well, be careful with this one now. The b in this problem is -2. The a in this problem is 1. So this comes out to be 2 divided by 2, which is 1. So the x value of the vertex in this problem is 1. The x value of the vertex is 1. Now, I want you to notice it does not give you the y value of the vertex. The formula only gives you the x value. Then you have to plug it in. So 1 squared is 1, -2, -3. So I've got 1 -5, which is going to give me -4. And this would be my vertex at 1 and -4. Now, as I said, I wanted to do this one because of a particular characteristic that it has. And that characteristic is this. When you can find the x values, the x-intercepts, the vertex is always halfway between the two x-intercepts. So from -1 to +3 is a value of 2, and half of 2 is 1. And that works every time, folks. If you can find the x values of the vertex, you add them and take half of it, and that's going to give you your x-intercept. Of course, I'd be the first to admit that using the little formula -b over 2a is foolproof, and that's what most people use in order to draw these graphs. Now, get used to one like this because they do present a little bit of a problem. But we should be able to handle it. In fact, if you can draw your graph with your graphing calculator now, that's going to take the pressure off of what the end result of this thing is going to have to look like. Same song and dance. Let's use the little formula, -b over 2a. In this case, b is -6, a is 1. So this gives me 6 divided by 2, which is 3. So the x value of the vertex is 3. Now, be careful when you plug that in. The x value of the vertex is 3. Okay, so this gives me -9, -18, -27. There's something wrong here, and I'm trying to look at it ahead of time to see. Here's the problem right here. In this particular problem, the a value is -1. Now, that makes a totally different ball game because that makes this a -3 right here. So this is -3 squared. This is -3. And this is still going to give me the -9, but this is going to give me a +18. And then this is going to give me 9. Now, so the x value of the vertex is -3. The y value of the vertex is +9. And that's what let me know that I had something wrong, because looking at this problem, the negative is in front of the x squared, which means that it had to go down. So that y value had to be up above the x-axis. So if you're going to draw the graph of it, you got your -3 and you got your 9. Now, look at the intercept thing again. When x is 0, y is 0. And also when x is -6, y is 0. Well, that just backs up what I said earlier. Halfway between -6 and 0 is -3. And that's where the x value of the vertex of this particular problem is. Now, he can ask you all those old questions, and he probably will ask you all those old questions. This thing, first of all, is concave down. It's going down. But on this side of the -3, this thing is increasing. So it's increasing from -infinity up to -3. But I notice that you don't include the -3 on the right side of the -3. So it is decreasing from -3 to positive infinity. Now he can talk about the range. The highest y value on this parabola is 9. So the range is y is less than or equal to 9. The domain is easy because the domain for all parabolas, unless it's restricted, is going to be all real numbers. In other words, you can put in any value of x and you get out u. What happens if we have one and the a value is other than 1? Three x squared plus 12x plus 9. Well, I think most of us are going to take the chicken way out. The x value of the vertex is going to be -12 divided by 2 times 3. So it's going to be -12 divided by 6, which comes out to be -2. Okay. And to find the y value of the vertex, you have to plug it in. So you got 3 times -2 squared, 12 to -2 plus 9. So this gives me 412 minus 24 plus 9. So I get -12 plus 9, which is -3. So the x value is -2 and the y value is -3. Now, I want to go ahead and follow through what I said earlier. Let's find the x-intercepts. So if I let y be 0, well, second day of class again, this is a quadratic, but we can do a little bit of arithmetic right here to make our work easier. Divide by 3, I get x squared plus 4x plus 3. So this factors into x plus 3 and x plus 1. Okay, so what's the graph of this mess? This is -1, and I won't exaggerate it over here. This is -3. Now notice what we found up here. We found that when x was -2, y was -3. That's my vertex. -2 -3 would be right here. And then this parabola goes up. So that little formula, x is -b over 2a. It also gives me something else. it gives me the axis of symmetry. In other words, I've done this 3 or 4 times. Every parabola is divided by the line that goes down through the x value of the vertex. So x is minus 2 is going to be the axis of symmetry for this particular parabola. So using the formula minus b over 2a to find the x value of the vertex, I know you have one like this in your homework, and it goes like this. Suppose that I tell you that f of x minus x squared plus 2. And I tell you that g of x is 2x minus 1. Well, the top one is a parabola, and the bottom one is a straight line. So let's take the parabola first. When x is 0, y is 2. I'm going to exaggerate it so we can put him up here. And there's going to be a parabola that's going to be opening down. Now, this is a straight line. When x is 0 and y is negative 1. And when x is 1, y is 1. That's kind of odd. I think that may be this point right here, but we'll find that out in just a minute. So I draw the graph of the line, and it looks like it crosses that parabola there, and it also crosses that parabola down here. Well, we can't draw it accurate enough on the piece of paper to do that. Now, you could draw it accurate enough with your graphing calculator to do that, but we can certainly do the algebra for it. So let's see where the two y values are the same. So this is the y value on the f of x, and this is the y value on the g of x. It's a quadratic equation for us to solve. So 0 is equal to x squared plus 2x minus 3. And lo and behold, it falls into place. This thing does factor into 3 and 1, plus with the 3 and the minus with the 1. So that says that x is 1 and x is minus 3. Well, when x is 1 and you plug it in, so we were correct, even with the sloppiness of our graph, that it crossed up there at the point 1, 1. Now, x is minus 3 is a different ballgame. So you want to find g of minus 3, which is 2 times minus 3 minus 1, minus 6 minus 1, minus 7. So this point down here then, when x is minus 3, y is minus 7. So we can use algebra to find out where those two values cross. Okay, that takes care of section 4. 4.5 is even an easier situation. Now, there are several ways to work these kind of problems. I'm going to work it 2 different ways, and then I'm going to let you make your choice as to which one that you think it is. Okay, sorry about that little bit of interrupt. Okay, let's do it the old-fashioned way. This factors into 8 and 1, both of them negative, less than 0. Okay, so if you put it on a number line, something happens at 1 and something happens at 8. Now, when you multiply two things together and get 0, get something negative, one has to be plus and one has to be minus. So watch what happens. Let's just go past 8 over here. Let's let x be 9. So if I let x be 9, this is going to be 9 minus 8, which is positive. 9 minus 1, which is positive. And a positive times a positive is going to give me positive. If I pick any number between 1 and 8, it doesn't make any number which you want. Let's just pick 5. Well, that means this is negative, and this is negative. Let's try it again. Let's let x be 5. Then this is negative, and this is positive. And a positive times a negative is going to give me negative. Pick any number to the left of 1. Well, the obvious one would be 0. So that will make this negative times a negative, and a negative times a negative. It gives me positive. So the answer to the problem then, if I use anything between 1 and 8, then that product is going to be less than 0. So the answer to the problem is that I use all the numbers between 1 and 8. Okay, and that's a foolproof method. It works every time. But to me, since we're real familiar with the graphing by now, we got a better method to do it. Let's just take that same equation and let's look at it as a graph. All right, it's a parabola. It's a parabola that's going up. It has an x-intercept of 1. It also has an x-intercept of 0, 8. And it has a y-intercept of also 8. So that means that the graph of that parabola is going to look like that. Now look at the parabola. Where is the parabola negative? The y values on the parabola negative. Well, all of these y values right here are negative. And this was for an x value of 1. And this was for an x value of 8. To me, that's the easiest way to work the problem because it works both ways. We're going to do a greater than in just a minute. But we will get the same answer. The answer to this problem is all points between 1 and 8. So, all right. I'm going to put the cart before the horse. We're going to draw the graph first. So when x is 0, y is going to be -6. And let's get my two x-intercepts. Let's let y be 0. So I got x squared minus 5x minus 6. So I got x, and I got 6 and 1. And that had to be a -6 and a +1. So it has an intercept over here at 6 and has an intercept back here at -1. Now, if my equation my problem would have been this. Where is this thing greater than or equal to 0? Well, look at it. All of these y values are positive, and all of these y values are positive. Now, I want you to keep that in mind, that every time it's greater than, it's going to be right and left of two values. So you're going to write it as two separate intervals in order to be able to get both answers. So the answer to this thing then is that I start at 6 and I go to positive infinity. So it's everything 6 and greater. But it's also back over here. I go from negative infinity to -1. Now I want you to notice that I'm using the bracket with the 6 and I'm using the bracket with the -1 because it was greater than or equal to. So to me, the graphing method is the best way. If you can draw that parabola, it's either going to go up or down, and then you decide where the x values are negative or where the y values are negative or where the y values are positive. That's always going to give you the answers to this mess. Okay, I hope I didn't interrupt the movie too much.